overview of a project that we've also just started and that we're in the early stages of, and that's looking at the impact of nitrogen deposition on limestone pavements. So for those of you that aren't familiar with nitrogen deposition as a problem, we're talking about atmospheric nitrogen deposition, so atmospheric pollution. And we know that across a wide range of habitats, it reduces diversity. We don't know about limestone pavements. The closest we have is calcareous grasslands, but national surveys have revealed negative impacts on the diversity of calcareous grasslands. Levels of nitrogen deposition peaked in around sort of between the 1970s and 1990s, and they have dropped from that level in the UK, but we still see levels that are higher than we would want to see. Critical loads, which are kind of the legislative limit, that sort of guidance for habitats on where damage is caused, they're exceeded in almost all habitats across most of the country. But nobody has looked at this in limestone pavements at all, and we don't have a critical load for limestone pavements. So we had some work this year that's been funded by JNCC to take an initial look using data that we already had at what the impacts of nitrogen deposition were likely to be on limestone pavements, and also, really importantly, to set up an experiment. So we were able to look at the national patterns, but really what we see is huge variability, basically. We have very noisy data. There's no clear relationship between species richness and nitrogen deposition. And the reason behind that really is most likely because when you're looking at a limestone pavement, we've seen this spectrum from kind of open habitats through to wooded habitats. We've got this huge variability. And so this graph is encompassing all of that variability. If we classify that, we might see something, break that down into different types of habitat. We might see something that is clearer, but that is really hard to do with the data that we've got at the moment. And we did have a go at it, but it didn't give us, we were unable to, based on the botanical data that we have from the repeat of the Warden-Evans survey, to get a good classification. And that is simply because it's not what the survey was designed for. So that's something we need to work on a bit more, on breaking that data down so that we can have a look at those relationships. And we did some modelling alongside that, but there were quite a lot of challenges with that and no clear relationships came out. So what we've been working on and what we're continuing to work on, hopefully over the next few years, is looking at experimental additions of nitrogen. So we set up an experiment early this year, late last year, and it's on a pavement at Ingleborough at Horton in Ribblesdale Quarry. And there's an area of quarry, an area of pavement there which you can see is really heavily damaged. So this is adjacent to the quarry, and the previous quarry owners were tarmac, just so that get this out there, deliberately destroyed big parts of the pavement so that they could quarry it in future. They got into a lot of trouble for that, and quarry has since changed hands, and this area is due to be quarried in the future, but they've had to put some areas aside for conservation and protection. So we work now with Heidelberg Materials, who are absolutely fantastic. And on some of the bits of this pavement that are intact, and they're not under any kind of protection because of the amount of damage in the area, we've been able to set up a nitrogen addition experiment. So we have small plots, with lots of replicates because we've got highly variable habitat, and we're adding nitrogen onto that 4 times a year to see what happens to that. So our plots, you can kind of just see what they look like. They're just little squares marked with spray paint, and we're looking at the vegetation in the grikes. And the hope is that we can keep monitoring those over the next 3 to 5 years. One of the benefits, hopefully, of having so many replicates is that we can, at some point, stop putting nitrogen on half of them and look at how the habitat recovers after that nitrogen stopped. And hopefully, in time, we can contribute towards an evidence base for a critical load for the habitat. So, an experiment that's only just being established at the moment, and we'll get our first year of data post starting nitrogen additions this summer. So that's that. Time for a quick question if anyone wants one. Yeah.
What's causing like or what did cause and now the decreasing cause of atmospheric nitrogen?
It's from fossil fuel combustion and agricultural emissions predominantly. So fossil fuel in the form of nitrogen oxides and agricultural emissions in the form of ammonia from animal waste. Obviously, you get local sources of that, but it also enters the sort of higher levels of the atmosphere, and then it's deposited in areas even where you haven't got local sources.
So the drop is because you stop burning some of the fossil.
Partly co-benefit of sort of carbon reduction policies, partly increased legislation around agricultural sources, and quite complex situation.
I can just add to that. I think it's like more increased awareness of the impact of high nitrogen, like high ammonia, and incentives to have mitigation measures. So you can have like ammonia scrubbers in agriculture on like cattle sheds or chicken sheds to help reduce like ammonia produced by them in their waste. For example, so I think it's increasing mitigation measures and awareness that's going to change. So it leads to a drop in nitrogen levels in the atmosphere.